ever-increasing volume of traffic using our already congested roads and predictions of more to come, safety on the road has become an increasingly important issue with all motor vehicle manufacturers, with increasing reliance on electronically controlled aids to improve the standard of driving. The Range Rover, with its immensely strong chassis and high-level visibility, has always left the driver feeling relaxed after a long journey. Added to this, the introduction of a state-of-the-art anti-lock braking system in 1990 now gives the driver peace of mind in an emergency situation, even with the brakes fully applied. As well as the obvious safety aspects, ABS offers many other advantages to the owner of today's Range Rover, such as a reduction in brake pad and tire wear, a much improved brake pedal feel, even when towing a heavy trailer, and the knowledge that the system is checking itself 250 times every second, so that if a reaction is required, it can be performed very quickly. The object of this training video is to guide you through the system in 4 sections. These are component identification, system operation, servicing the system, and diagnostics. The system itself was developed by Land Rover engineers and WABCO in Germany over a 5-year period. It has 4-channel control, power hydraulics, the ability to cope with a very stiff viscous coupling unit, and an electronic control unit, or ECU, dedicated to the Range Rover drivetrain. Five major components go to make up the system. First of all, the pump, which is driven by a 12-volt electric motor and controlled by a series of integral pressure switches which supply the power section of the system with brake fluid. These pressure switches are also responsible for controlling the low pressure warning light on the instrument cluster and informing the ECU if the pressure is too low for ABS control. Second, we have the accumulator, which stores hydraulic energy. It is a very strong steel sphere split internally into 2 halves by a thick rubber diaphragm. One side is exposed to brake fluid under pressure from the pump. The other side is pre-charged to 80 bar with nitrogen. Then we have the booster unit, which is located in place of the vacuum servo and master cylinder used on non-ABS vehicles. This unit directs the brake fluid to the calipers and receives messages from the ECU for ABS control. We will look at this in more detail later. The fourth set of components are the magnetic sensors and exciter rings, which inform the ECU when a lock situation is imminent, enabling it to take controlling anti-lock action. Fifth, we have the electronic brain of the system, the ECU. This is located under the driver's seat along with relays and fuses associated with the ABS system. Since the next section is concerned with the operation of the system, it is worthwhile identifying the relays and fuses at this point. Starting from the left, we have the ABS warning light relay, whose function is to display the warning light should power be lost to the ECU, or if the 35-pin ECU connector becomes disconnected. Next to this, we have 2 5-amp fuses protecting the 12-volt feed to pin 9 of the ECU and the pump relay, and one 25-amp fuse supplying the power feed to the valve relay, whose function is to supply the ECU with power to energize the ABS solenoid valves if the need arises. Finally, we have the pump relay, which is controlled by the pump's integral pressure switch and supplies a 12-volt feed through the 30-amp maxi fuse when the pressure drops below 130 bar. The 1992 Electrical Troubleshooting Manual contains in-depth circuit diagrams and fault-finding charts to assist you in the diagnosis of possible faults. System operations. In this section, we will look at how all the separate components in the system interface with one another, both under normal braking and in the ABS mode. On a non-ABS Range Rover, the braking system is comprised of primary and secondary circuits. The primary directing brake fluid to the top 4 pistons of the front calipers, and the secondary feeding the bottom 4 and the rear calipers. This is to ensure that if one circuit fails, the other will still provide adequate braking. On ABS vehicles, the primary and secondary circuits are replaced by the hydrostatic and power circuits respectively. The hydrostatic circuit works in much the same way as a normal brake system and is designed to give the brake pedal some degree of feel. The power circuit operates in tandem with the hydrostatic circuit and is simply a valve, which will feed fluid to the calipers under varying pressures depending on the degree it is forced open. It is also responsible for fluid supply under ABS control. Under normal braking, both straight ahead and cornering, fluid is fed to all calipers, with the pressure retardation dependent on the force of the driver's foot. The ECU constantly receives messages from the wheel sensors and monitors the brake light switch, which informs it of actual braking. The sensor signal denotes the average deceleration of the vehicle. Should any one sensor show a deviation from this average, that is, a wheel going into lock, the ECU instantly takes over, first blocking the hydrostatic circuit to reduce excessive pedal vibration during ABS control. The anti-lock solenoids in the booster unit are then pulsed to reduce, hold, or increase fluid pressure to each individual caliper to achieve maximum stopping effort on any surface without allowing the wheel to lock. When the vehicle is under ABS control, the driver will notice that the brake pedal drops somewhat, feels very hard, and vibration can be felt through the pedal. This is perfectly normal and is the effect of the solenoids in operation. The driver will also notice that when braking normally, the pedal feels much firmer with less pedal travel than a vehicle with normal vacuum servo assisted brakes. Servicing the system. When servicing the braking system, it is important that genuine Range Rover parts are used and cleanliness is maintained at all times. Recommendations from Range Rover regarding brake fluid and hose replacement intervals are given in the appropriate maintenance schedule. It is recommended after depressuring to install the pressure gauge LST-140 to the pump before a fluid replacement to check the accumulator precharge and pump pressure switches. First refer to the workshop manual, Section 70, page 65 in the American version, Section 70, page 22 in all other versions. You may also refer to Service Bulletin P91-005 for specifications. The graph shows that when the pump is operated from zero pressure, there is a rapid pressure rise to the point where the space under the diaphragm is filled. The point at which the rate changes indicates the pre-charge pressure inside the accumulator. If the pressure is below 50 bar, a new unit must be installed. The pump will continue to run until the high pressure limit of 170 bar is reached. LST 140 can be used to ensure this pressure is reached. If you slowly pump the brake pedal, the pump should start again at 130 bar. Now pump the pedal faster and the low pressure warning light will illuminate at 100 bar. Let the pressure rise again and it will extinguish at 120 bar. This has effectively tested the pressure switches contained in the pump. Should a component other than the pump or accumulator require replacement, it will be necessary to bleed the system following the instructions in the workshop manual, section 70. The importance of following the correct procedure cannot be overemphasized, as error in the system will result in poor pedal feel and reduced system performance. First, bleed the hydrostatic circuit, starting with the outer driver's side bleed screw. This is followed by the passenger side outer, passenger side inner, and finally driver's side inner. Then the power circuit can be systematically bled.
Ignition on. Press the brakes.
An assistant will be required to operate the ignition and brake pedal while you open and close the various bleed screws. After fully bleeding the power circuit, make certain the reservoir is topped up using only .4 brake fluid. Repeat the bleeding sequence on the hydrostatic circuit. This operation must be repeated to ensure a good solid feel to the pedal. We will now look at the wheel sensors. If the vehicle is used extensively off-road, the rear wheel sensors should be checked for abrasive wear at 1,000 mile or 1,600 kilometer intervals. When replacing the sensor, the retaining bush and seal must also be replaced, remembering to coat the rear sensor with silicone grease. The correct grease is specified in the workshop manual. Insert the sensors as far as they will go. Rotation of the wheels automatically sets the correct gap. Finally, it is important to note the installation procedure for the brake light switch. The switch plunger should be extended, as shown, and then fully pushed into the brake pedal bracket. The locking tube is then pressed in to secure it. Pull the brake pedal back to set the switch to its correct position. Operation can be tested as shown in the next section. Diagnostics. The heart of the system, the ECU, is equipped with an electrically programmable and erasable memory capable of recognizing and storing up to 60 possible faults. The first indication that a fault may have occurred will be the illumination of the ABS warning lamp. However, it is important to understand that the warning lamp will also remain on if the pressure in the system is below 100 bar or the vehicle speed has not exceeded 5 miles per hour or 7 kph since the ignition was first turned on. There are two methods of integrating the memory if you suspect a fault. These are using the WAPCO tester or using the onboard blink code and multimeter check. Either of these methods should be used in conjunction with the electrical troubleshooting manual. The WAPCO Diagnostic Controller STC2 allows direct access to the diagnostic memory and also leads the technician through a prompted diagnostic path to enable right first time fault finding. Other advantages of using this equipment include the ability to operate various circuits otherwise not possible. Let's run through its functions. After connecting the unit to the diagnostic port, as shown in the manual, and selecting Diagnosis, you will be presented with a menu containing the error memory, measured values, valve test, and switch test. Before looking at the error memory, let's see what other functions are available. After selecting measured values with the cursor, you are presented with two options. Wheel speeds denotes output from the force sensors converted to kilometers per hour. The 1.7 kilometer per hour figure on the screen is the lowest speed the ECU will recognize. Below this, it is considered stationary. The maximum the tester can register is 7 kph. Operating voltages displays the supply voltage to pins 1, 19, and 9 of the ECU, which also checks the operation of the valve relay. Selecting the valve test with the cursor allows you to check the anti-lock solenoid valves and isolation valves in the booster. The isolation valve test simply requires you to count the number of pulses on the brake pedal and subsequently enter yes or no. The solenoid valve test checks each pair of anti-lock valves and is best performed with the vehicle on a hoist with the wheels free to rotate. Following the instructions given on the screen, the tester automatically runs the test sequence. An assistant is required to check that the wheel being tested rocks in the 10-second period. Again, a yes or no response is required. If the booster is found to be faulty, it must be replaced as a unit, as there are no serviceable parts. When the switch test is selected, again two options are highlighted. Brake light switch allows you to check the correct operation of the two-stage switch without having to use a multimeter. Low pressure switch, especially when used with the pressure gauge LST 140 as shown earlier, gives a direct readout of the switch position. You must remember that the light also signifies handbrake on and low fluid level. Therefore, make sure the brake is off wheels chocked and reservoir full before testing. Having demonstrated the range of tests available to the technician, we can now return to the error memory to see how it functions. When the error memory is selected, you will either see a message telling you that no errors are stored in the ECU, or if a fault does exist, it will be displayed as shown. In this case, it is a wheel sensor with a broken wire. If you were to press enter now, the screen tells you that there are no further faults. If you continue, the tester will tell you that it is not possible to clear the memory, as you must attempt the repair option given to you on the first screen. So return to the first screen and press repair. The first thing to do is to check the wiring. If a fault is found, repair it. If not, press no and continue. You are now told to carefully remove the 35-pin multi-plug and fit the breakout box supplied as part of the tester kit. The next screen provides a direct readout from the tester's built-in multimeter compared to the correct reading. At this point, if the reading is still incorrect, press no and the tester will direct you to measure the resistance between pins 15 and 27 and at the breakout box. This has the effect of checking the harness for short circuit to ground. At this point, the fault should have been located, but we will press no anyway to proceed to the next test, which shows the AC voltage output of the sensor. If the fault is not repaired at this point, the tester directs you to the workshop manual. but as already mentioned, enough testing has been covered for the technician to locate the fault by this stage. If a WABCO tester is not available, the memory may be accessed using the blink code as follows. After removing the access panel and side trim from the seat, remove the ABS warning light relay. Using a pre-wired jumper plug, connect the black and pink wire in the diagnostic plug to the black wire. Now, turn the ignition on, and after a few seconds, the ABS warning light will start to flash. This is the start phase, and Section 70 in the workshop manual should be referred to in order to fully understand the sequence. After the start phase, a 2-number code is flashed and should be written down and checked against the table in Section 70 of the workshop manual. In this case, it is code 28, which is no feed to the ABS solenoid valves. This should now be investigated using the breakout box and multimeter. The test and values to be expected are in the workshop manual. To clear this code, or to retrieve another fault, should one exist, the pre-wired plug must be disconnected with the ignition still on. You must wait until the ABS light stays on continuously before the previous fault is cleared from the memory. This method of clearing fault codes must be adhered to, as the ECU retains faults even with the battery disconnected. Reconnecting the pre-wired plug will now initiate the next fault. If there are no faults present in the memory, the 2-number code is replaced by a 7-second pause. This concludes the diagnostic section of this video. In summary, this video has familiarized you with the Range Rover anti-lock braking system and demonstrated to you, the technician, the range of diagnostic tools at your disposal. Armed with this knowledge, you can ensure fast, efficient service, maintaining total customer satisfaction at all times.